Welcome to all of you. This is the Becoming an OpenSolaris Power User tutorial. I'm Dave Miner. I'm one of the authors of OpenSolaris Bible, and Nick Salter here is my co-author, actually the lead author. He was the real driving force behind this book, which ate 2008 for both of us. That's what we spent most of last year doing. So before we get started, just wanted to ask a little bit about your background. How many of you have actually tried OpenSolaris to this point, downloaded it, installed it, used it very much? A little bit? Okay. About what I expected then, which is good. Yeah, so in our day jobs, Nick and I both work for Sun. I'm one of the leads for the OpenSolaris project, run the installation technologies, do lots of other random tasks. And Nick's in the HA clustering. This is his primary job. So the OpenHA cluster project that you'll see on OpenSolaris, that's him. So we've got a whole lot of stuff. So this is scheduled till 5. There's a break scheduled starting at 3 to 3:30. We hopefully will be at a good breaking point at 3 o'clock. We may run a couple minutes over that, but we're doing our best to try and be on that. So, just a quick outline of the agenda here. We'll run through a quick introduction to the OpenSolaris project and community and such. Talk about some of the basic installation and some of the real basic features, and then I'm going to switch it over to Nick, and he's going to talk about security and SMF, and then I'll come back and we'll do some on ZFS and the software management capabilities. And then Nick will come back and we'll talk about network virtualization, the Crossbow project that you may have heard of, zones and dtrace, and then we'll wrap up with a little bit of troubleshooting and some resources. So, and if you've got questions along the way, ask them. Just raise a hand and we'll do our best to answer them. So the OpenSolaris project is at this point 4 years old. June 2005, we launched it publicly. Actually, we started the project over a year before that, actually almost 2 years before that, and working through all the logistics of open sourcing. This is one of those, something that really nobody had ever done before, taking a proprietary OS and open sourcing it. We had 25 years of code history almost that we had to go back through to do this. So there was a substantial lead time in actually putting together the OpenSolaris community. We had a pilot project that ran for several months with a small set of the community to start getting access to the code and giving us feedback on how we could set it up. When we did launch it, Sun actually defined the relationship with the community with a charter document, which is available on the website. Describes briefly how Sun relates to the community. And there's a constitution that was created after the first year, which covers the governance of the community. So there's a governing board that's elected by the community members, and then there's a structure that's defined in the Constitution around that of communities and projects and user groups are the main entities in the community. The code is primarily licensed using the Community Development and Distribution License, or what we call CUDL, it's a copyleft license. It's not GPL, but it has some commonalities with it. Problem there are some incompatibilities between CUDL and GPL, which prevents mixing of kernel code. So that's something that you'll see is a topic that's discussed a lot in some of the communities. With respect to the trademark, Sun owns the OpenSolaris trademark. There is a trademark policy that's published to the community defining the terms under which others in the community can use that trademark. It's a reasonably liberal policy. So that's kind of the community. The interesting thing for us as engineers is the code. So just a little bit of an idea of how OpenSolaris is put together. As we build each release, parts of the operating system are managed by these things called consolidations. Essentially, they're source trees that are built. So there is not one gigantic source tree that builds all of the OpenSolaris distribution. There's a series of source trees that are built that deliver packages, and we aggregate them together to build the operating system. So the OSNet is probably, if you've got a Linux background, this is the thing that's most similar to the Linux kernel tree. The kernel code and core user land is there. But then we have a build of GNOME that's run by our desktop consolidation, the X server, which is the Xorg server, and then a supported open source code thing called SFW for Solaris freeware, which is, we're in the process of working through opening that process up more, so that it'll be run more by the community going forward. So the code, the consolidations usually pick up code from projects and deliver them to the distributions. Now the OpenSolaris distribution, which we'll talk about in a few minutes, is actually a little bit interesting in that, unlike most of the cases, we're actually using code directly from the projects that hasn't gone into a consolidation yet. And in this case, it's the IPS packaging system and the Cayman installer. And this is because these are under active development, but we feel they're good enough that we can actually build a distribution around, and that's what we've been doing for the last couple of years. If you look at how the source code is managed, we've got two source code management systems that are supported on the site infrastructure: Subversion for centralized management, and Mercurial for distributed source code management. And I'm not going to spend any real time on the differences between the two, but we mostly use Mercurial for most of the source. Subversion's used for a few cases. One of the things that we have in OpenSolaris, if you're familiar with Solaris, that we've talked about for many years, is the binary compatibility guarantees that we have. And a lot of those are managed by what we call an architecture review process. And so there's this body called, there are several bodies called ARCs, or architecture review committees, that manage reviewing of projects essentially in their design phase to discuss the interfaces that they're going to be providing. So this is how we define the boundaries of projects and how they relate to each other. And this is the way in which we get the binary compatibility that we have going forward. The community contributions to the various consolidations right now are run through a sponsor program for most of the consolidations. If you want to contribute kernel code, there's a little sponsor program where you ask to work on a bug or integrate some project, and the Sun assigns a sponsor to shepherd you through some of the processes, which haven't, not all the processes are out in the open outside the Sun firewall yet. But we've been working on moving those over, and we continue to make progress at that. So that's the basic process that's used there. And browsing all the source code, there's actually a very nice web application that's been written by members of the OpenSolaris community that provides our source code browsing capabilities on the website. So all of the projects that are hosted on the website and the consolidations, the published code, they're all browsable and searchable by the source.opensolaris.org pages. So, in 4 years, we've actually had a lot of distributions already built out of OpenSolaris. The original one is this thing called the Solaris Express Community Edition. And what it is essentially, it's the evolution of Solaris 10 into OpenSolaris. So when we started the next release of Solaris after Solaris 10, we started releasing it as open source in Solaris Express Community Edition. So the interesting thing about this is that it still has the old installer and SVR4 packaging system that are used in the older Solaris releases, which is different from the OpenSolaris distribution. This distribution, the SXCE, is probably going to terminate being distributed within the next few months, as our need for it has essentially dissipated at this point. Shillix is an interesting distro that was the first one that was built right after the source, right after we opened the source. Jörg Schilling from Germany actually built a small distribution within the first week after we had open sourced the technology. He's developed it a little bit here and there. Belinux is a distribution done by the Indian community primarily, and it's very interesting. It actually has developed a lot of the key technologies. The live CD that we have in OpenSolaris was actually pioneered by Belinux. And we've got, they focus more on KDE and some lightweight desktop technologies. Nexenta is an interesting one that's glued the OpenSolaris kernel with the Debian packaging system. Has a very large number of packages available through it, and they've built some storage appliances off of it. Milax is another interesting one with a small footprint that's been under development lately. And then there's a couple that are very new here. I've got listed Eon and Yaris. Yaris especially is interesting. It's a focus of the Japanese community. We've actually got a very thriving community in Japan around OpenSolaris. So the OpenSolaris distribution is basically, what we've tried to do is repackage Solaris into a modern distribution with a really easy to install, easy to download, easy to get, fully redistributable. So we can hand out CDs, you can pass them along to everybody. There's no distribution limitations like there are on the older Solaris releases, and easy to update with network packaging. It's most all open source. We've been releasing it for a little over a year now. We've done 3 releases. On roughly a 6-month cadence, and that's what we're intending to do going forward. And this is going to be the basis for the next Solaris Enterprise release. So that's kind of the 5-minute, 10-minute introduction to OpenSolaris. Real basic flyby of what the community's like and how a lot of things are put together. So let's take a look at, so really in the rest of this talk we're going to be looking at the OpenSolaris distribution primarily. And if you read the book, that's primarily where we focused our discussion of the technology. So you download it, you go to OpenSolaris.com. There's a really nice download site to get the media from. Those have the releases, the semi-annual releases. In addition, every 2 weeks, roughly, we release development builds of OpenSolaris. So there's actually an update to the package repository, as well as new installation media, new live CDs and such, that we release every 2 weeks. So if you're really interested in being on the bleeding edge and running exactly the same things that those of us developing the OS are, you can get it. This is where you go. There's 4 downloads right now, a live CD and a USB image. That's the same as the live CD, but it's designed for USB sticks. And then there's automated installation boot images, and we'll talk about those some more later in the tutorial. So, basic requirements around install. Need something reasonably modern, but not exceptionally modern. Pretty much anything that's in the last 7 or 8 years should work. Question over there. Yeah, so how do you update along the development releases? And we'll talk about that some more later, but yes, essentially every 2 weeks you can update, use the packaging tools to update from the repository to the next release. And it's actually extremely efficient, and we'll talk about that a little bit more later. But that's, basically the idea is you install from the media once to start with, and then your updates are out of the package repository over the network from there. We need a primary partition. One of the limitations in OpenSolaris right now. We just recently added extended partition support about 2 weeks ago, 3 weeks ago, to the operating system. That hasn't filtered its way into the installer yet. That'll happen in the next few months. So right now you actually have to, on an x86 box, you have to have a primary partition in order to be able to install. Need at least 512 megs of memory. You download, burn the CD or USB. The USB images right now, you either have to have Solaris to burn them, or there's a Windows utility for it. We don't actually have anything for Linux. If somebody wants to write that, that'd be a good idea. We just haven't gotten around to it yet. If you're going to want to, most people are going to want to install OpenSolaris, try it out, and they've already got an operating system. So, what can you do to coexist? And the thing I always recommend is, well, if you've got the horsepower and you've got a reasonably modern laptop or desktop, it should run virtualization technology really well. So something like VirtualBox or VMware is really a great way to try this out, because then you just download the ISO, create a virtual machine, point it at the ISO, you can boot it up, try it out, install it, and we'll actually show that in just a minute, how we do that. You know, and that may be all you ever need to do, if that actually meets your needs. If you really want to run it directly on the metal, well, then you know, get into multi-booting and things like that. The OpenSolaris installer right now can't do all the partitioning you might like. So in a lot of cases, you'll end up needing to use a utility like Parded, or if you've got Windows Vista, there's a utility there for shrinking their partitions to free up space for OpenSolaris. One thing to be aware of with OpenSolaris is that we use Grub to boot on x86, but it's our own special branch of Grub because it actually has support for the ZFS file system, which is not in the mainline Grub. So our Grub can boot any of the Linux distributions, but the Linux distributions Grubs can't directly boot OpenSolaris. In those cases, you end up having to use something like chain loading between the different partitions and, you know, multi-stages of Grub to actually do that. So when you boot the live CD, here's the initial boot screen you get. You know, the top one is a standard selection, default selection, which will boot you to a desktop. Second one allows you to, and you know, automatically, X will automatically configure to the right display driver. If that doesn't work, sometimes you end up having to come back and try it with the Visa driver instead. And that occasionally is necessary. If you've got real problems, you might need to use the text console, which just boots you to a text login prompt. And then there's these last three options are for accessibility and testing purposes. You can enable SSH so that you can actually log in remotely to the live CD if that's needed. And then these last two are around accessibility for people with disabilities. The initial desktop, it's a pretty standard GNOME desktop. A couple panels on it, a bunch of you know, applications such as Firefox and Thunderbird. Nothing all that exciting here. You know, some interesting, you know, a few small things to note are the device driver utility, which I'll come back to in just a second, and the installer is right on the desktop to open. And there's a getting started guide that you get with Firefox that you can read with Firefox. So this device driver utility that we have is actually, and I'm actually going to switch to, I've actually got one running here on the laptop. So this utility allows you to check out the support for your devices with OpenSolaris. There's also some utilities on some of our websites that you can actually go without actually having to boot that can tell you something about how well OpenSolaris will run on your system. But this is, you know, the most definitive tool that you can use. You boot OpenSolaris, run the device driver utility, and as you can see, it shows you, you know, what devices are on the system and whether we have drivers for them. And as you note, as you can see on this display, there's actually one driver on my laptop here that we don't have support for, which is a TPM module. That's something that's coming someday, but right now we don't have a driver for it. Not a big deal to most people at this point in time. And you know, a couple of nice things here is that if you look at the bottom, we've got an install all drivers. So if there are missing drivers, but you'll occasionally see here a driver listed as missing, but we can point there's a place we can download it from. And with the install all drivers, that can actually, you know, the tool can actually do that for you automatically. And this submit button here allows you to actually send a report back to us at Sun so that we can take a look at what we should have what device support we should be adding going forward. So we're actually, you know, we're building a nice database of how well we're supporting things are out in the community. So we'll just quickly take a look at the interactive installer, which is, so in this I'm actually running in VirtualBox, as I was alluding to before. The live CD I have booted, and here we have the desktop with, unfortunately got some limitations to resolution here, so I'm having to do a little bit of panning around. But we can start the installer. Yeah, there we go. And the initial screen here is a quick welcome screen that gives you a pointer to the release notes, which are published on the web for each release. Allow you to check out any issues that we couldn't get into the documentation. So your first step is pick a disk to install on, and in this virtual machine I've only got one virtual disk. You can choose to use the whole disk, or you can choose to partition the disk, and then you can select the size of the partitions you might want to have. We'll just basically let it have the whole disk in this case. Moving on, we can select the time zone. There's you've got drop downs and things to select from here, or there's the map that you can blow things up on and then select by location, although it's a little tricky sometimes. And get the right time set. Selecting the default locale in which you'd like to run. We actually, as you'll see, we have a very extensive list of languages available. Somewhere around 50 different translations are included on the live CD. And then, the last few things are pick a root password and type it right. And an initial user account to create. We get to this point, and that's all we need to do the install. And we can fire off the install, and it'll go ahead and run for us. Since that would take a little while, and we'd like to do something interesting, I'll stop with this at this point. So that's the interactive installer. And once you're installed, what do you have a choice of? What can you expect to see? So there's a choice of shells. They're included. Some things that are much more modern than you've seen in Solaris. For example, we've finally got a modern version of KSH. Solaris 10 is still using KSH 88, which has got a lot of limitations to it. For example, the default shell that we use for the root account and for user accounts is Bash. Which will be real familiar to everybody with Linux backgrounds, but is not something that people with Solaris backgrounds have been accustomed to. The default path, we actually have the GNU utilities as actually preferred over the Solaris utilities, and so one of the things that you see in the Solaris user land is we'll have both the traditional SVR4 based command line utilities that provide all the compatibility we've had in the past. But we've also got, where possible, we've merged the GNU utilities with them, or we've also just provided the GNU utilities as alternatives. So, if you've got, you like less better than more, and all these other interesting utilities. VI, and we've replaced with Vim, so we actually got a reasonably good text editor there instead of a VI from 1984. And the basic desktop, as I said before, it's GNOME, it's X11, the very recent Xorg builds, Xorg 7.3 I think we are right now, or 7.4, I can hardly keep track, but we're essentially as modern as anything you'll find in that respect. And choice of the Metacity window manager or Compiz if you've got 3D acceleration available to you. And in future releases, you can expect that we'll make Compiz the default window manager, since 3D acceleration is getting so common. Multimedia, always an interesting topic with open source operating systems. Because OpenSolaris is redistributable, we do not have any of the encumbered codecs included with the operating system on the media, but we've worked out a nice arrangement with the people at Fluendo who provide implementations of the various codecs, for Windows media and anything else, DVD playback, and the Codina utility gives us a very straightforward access to Fluendo's web shops, where you can download for a fee those codecs and install them. And in my case, I bought the whole set of them, and I tell you that they work very well. Network configuration. Those of you who've ever used Solaris in the past, know that configuring networking on Solaris has been tedious, difficult. There's lots of bad things we can say about it. One of the things that we've done in OpenSolaris is we've built this technology called Network Auto Magic. And really it's designed to be as simple as anything you've seen on Windows or Mac OS, where we just swap between the networking without you having to actually do anything. So Network Auto Magic comes up, it detects all of your network interfaces. If there's something plugged in on a wired interface, it'll try to use that in preference to anything else. If it can't use that, then if there's nothing plugged in, then it falls back to the wireless interface and automatically configures via DHCP there. So we'll actually just take a quick look here. So there's actually this tray applet, if you can see at the upper right of the screen, which actually shows us the status of Network Auto Magic. And in this case, we see that I'm connected to the OSCON wireless network. I can right-click on it, and then I can select if there's something else that I would prefer to use, if I'd like to use a wired interface instead of the wireless or something like that. We can also manage the priorities of the network interfaces, and I can say, oh, I would actually prefer to have wireless preferred over wired instead of the usual case that we have. Another thing we can do is we can actually, if there was a wireless network that we wanted to use that wasn't broadcasting its SSID, we can actually enter it here, and we can also set up wireless security settings if you're using WAP or WPA, and actually enter the keys and such. So it's very nice, very simple option. It's got some limitations right now that only allows you to configure a single network interface at a time instead of having multiples. But Network Auto Magic, like everything at OpenSolaris, is really under development, and there's actually a new version of it coming out within the next couple of months that'll have a much richer user interface than this offers, and more options for configuring static networking and multiple network interfaces. If you do want to convert to using, static IP networking, say you've got it's a desktop that's never going to move anywhere, or it's a server, you can use the GNOME Network Manager applet, just like you would on anything like Red Hat or Ubuntu. Printing's an interesting topic. We've actually got two printing subsystems in OpenSolaris. We have the old LP subsystem that comes from SVR4. And then we've got the CUPS, Common Unix printing system that Apple develops. You get to choose which one you prefer. There's really a couple of ways in which you can make your choice. Right now, there's this thing called Presto automatic network configuration that we've supplied in OpenSolaris, and you see on the screen here. This little dialog. So what happens if you're using the LP subsystem and you log in to OpenSolaris with a printer that's connected to your system, we'll automatically see that, and in this case this was seeing an HP printer that was connected to my desktop at home over USB. So as we log in, we've got the Presto applet that runs and says, oh, there's a printer here. All offered and automatically configured. So it pops up the dialog, and as you can see, it's actually figured out that, oh, I've got an HP printer there. It's a PSC 2400, and it'll automatically. So I can just click Add, and I'm done. I've got printing configured. So that's really nice. But if you're really familiar with CUPS, you'll like CUPS. There's a simple command called print service, which allows you to switch from LP to CUPS. Then you can use CUPS, and it'll be the same CUPS that you see anywhere else, and you can manage it through its web interface. And additionally, we've got a utility called PPD Manager to allow you to manage the PostScript printer definitions if you get printer definitions that come from other sources than the standard packages that we distribute. Power management, that's actually been an area that we've done a lot of development on in OpenSolaris over the last couple of years. So we've actually got some suspend and resume capabilities. It's a limited set of models at this point, but there's two Toshiba laptops that actually you can order with OpenSolaris pre-installed, and we've got complete support for suspend and resume on those models. And there's actually a number of models that are very similar to them, which it also works on. So you've got a really nice capability for using laptops. We've got a power-aware dispatcher that's gone in, and it works really well with the newer Nehalem or Core i7 processors. So we get really good management of the power, CPU power usage. And then there's a utility called PowerTop, which Intel has developed, which you can use for monitoring your power consumption on your system. And that's something that we've provided in OpenSolaris as well. So that's kind of the basic, that's a real fast rundown of all the basic features in OpenSolaris that we're not going to really cover any of them in more detail. From here, we're going to go on to a lot more detail on most of the other areas of the operating system. And I'm going to switch it over to Nick to talk about security.
Hello, everybody hear me back there and in front? Good. So I'm going to talk a little bit about security in OpenSolaris. So here's a highlight of the security features that you find in OpenSolaris. First of all, there's something called secure by default, and all that really means is that most network services, so for example FTP, Telnet, all those services except for SSH are off by default, or they only accept connections from localhost by default. So out of the box, when you install OpenSolaris, whether you're using it as a desktop or laptop or server, it's going to be fairly secure. You shouldn't be too worried about hooking it up to the network because it's fairly secure out of the box. Role-based access control is the, that's actually what I'm going to talk about in a little more detail. So I'll skip over that one for now. IPsec is available. So IP security, which is the IP layer network security standardized protocol, and you can find implementations on most platforms, and so OpenSolaris, of course, has that built in as well. There's plenty of logs and auditing that you can enable. Kerberos, which is a network authentication system. There's an implementation available on OpenSolaris. And trusted extensions, which is something that is somewhat unique to OpenSolaris. It's a security model that uses labeled security, and it's really useful for implementing hierarchical security models like that used by the US government, for example, where you've got secret and top secret and confidential, those different models, and you can have your secure labeled containers on the same system and without fear of cross-contamination between the different layers. And I don't have time to get into that today, but there's more information online about that. We actually didn't even cover trusted extensions in our 1,000-page book because there's only so much that you can talk about. So what I am going to spend a little bit of time here in security is role-based access control, because this is something that is a little bit different from what you might be used to on Linux. So what happened to root, basically? So the traditional Unix model is that you have a root or a super user that's all-powerful, and then you have everyone else. The problems with the traditional model, there are several, but there are two main problems that I've called out here. The first is that root is simply too powerful. Anyone with root access can do essentially unlimited damage to your system. And that doesn't even have to be malicious. So sure, if a hacker gets into your system and gets root access, then you're screwed. But if even a clueless administrator, if you're running a system and you want to delegate administration, if you only have root and everyone else in the traditional model, then you have to give all your administrators root access. And then if you have a stupid administrator who does something dumb, then your system can get hosed, right? So that's really the second problem here, is that there's no way to delegate administration in the traditional model. You have multiple people all using the root account, and so you have increased opportunities for someone to accidentally screw it up, and you have increased opportunities for attackers to get in. So the solution, in a general sense, is called least privilege. And what that means is you assign to users the exact privileges or authorizations or rights or whatever you want to call it needed to do whatever they actually need to do to use the system or to administer the system. So in OpenSolaris, the native approach is called role-based access control, and it's abbreviated RBAC. That's how we refer to it. That's the native Solaris and OpenSolaris approach. You may be more familiar with Pseudo, which is available on a lot of Linux distributions and on Mac OS as well. I see a lot of Macs out there. That's the default administrative model on the Mac. So Pseudo is available on OpenSolaris as well, so you can use that instead of RBAC if you prefer Pseudo, and I'll actually show you both here in just a couple minutes. So let me get into a few more details about RBAC. There are three concepts that you need to understand in RBAC. The first is an authorization, and what that is it's just a fine-grained capability for a specific task. So you can give someone the authorization to, say, modify the state of services on the system. A rights profile is simply a grouping of authorizations, and then a role is similar to a user. The differences are that you cannot log in as a role directly. What happens is that roles get assigned to users, and then you log into a user, and then you can SU to the role from that user. And roles can get assigned authorizations and rights profiles. And users can get assigned authorizations and rights profiles as well. So what does this look like? In OpenSolaris, out of the box, Dave just showed you an example of using the interactive installer to set up your OpenSolaris system. And if you remember in one of the screens, he created a user. And so when you do that, when you create a user in the installer, then what happens is that root gets made a role. So you cannot log in. So after the install completes that Dave gave a demo of, you cannot log in directly as root. You can log in as the user you created, and then you can SU to root if that user has been assigned the root role. So I'll show you what this looks like in just a minute. The default user that's created in the installer has something called the primary administrator profile, along with a bunch of other profiles, and is also assigned the root role. But with the primary administrator profile, you can actually do everything you need to do to administer the system. So you never need to actually assume the root role. Okay, and this is just like on the Mac. You just do your administration, and then every once in a while it'll pop up and say enter your password because I'm doing something that requires a password. And that's using Pseudo, but it works similar in OpenSolaris, and I'll show you what that looks like. The difference is that to execute a privileged command in OpenSolaris, you actually need to explicitly tell the system that you're trying to execute a privileged command. And the way you do that is you prefix the command with this pfexec command. And that stands for profile exec. Or you could start explicitly what's called a profile shell, which is this. We have two. There's pfcsh and pfsh. So it's the C shell and Bourne shell versions, and they're called profile shells. Or you can just su to root if you have root assigned. So let me just show you what this looks like here. So here's a user. Here I have a shell, and this is the user that was created in the installer on this physical system. So if I look at my profiles, I have, you can see the first profile listed there. Can you all read that in the back? Okay. The first profile listed there is the primary administrator profile. And then there are a bunch of other profiles. So let me my notes here. So here's another user over here that I created that is not the user I created in the installer. So you can see that this user doesn't have the primary administrator profile. Let me move that over. There we go. So that user doesn't have the primary administrator profile. So if I go back to so if I go back over to this user and I try and create a file, say in/etc, that's a protected area, so it's going to give me a permission denied message. But this user, remember, has the primary administrator profile, so if I want to do that privileged operation, I can do pfexec, and then it'll let me do it. Okay. Right, so there it is. Now if I try to remove it, right, yeah, it won't let me do it. It gives me a permission denied. So remember, I have to do that pfexec thing, or I can actually get into a profile shell. So if I run pfcsh, for example, that's going to get me into the profile C shell, and then I can run privileged commands from here without using pfexec. Okay? So if you notice here, in this shell with this user, this is the RBAC demo user, does not have the primary administrator profile, so if I try and touch file, I get permission denied. Even if I use pfexec, I still get permission denied. Okay? So if I go ahead and assign, I can assign this user, this is the RBAC demo user, I can go ahead and assign that user the primary administrator profile. So okay, so now that I've done that, now I can go ahead and see that operation, that privileged operation will succeed, because now this user, see, has the primary administrator profile. Okay. Yes?
How painful is it to create a profile that will just allow read access to
it's
more fine-grained?
Yeah, so the question is how painful is it to create your own rights profiles that are more fine-grained than the primary administrator one? It's not that hard. It's pretty straightforward. You just edit. There's a configuration file that you can go in and add it to directly. I can show you later if you want. Yeah. So, okay, so let's talk about roles for a minute. So this primary administrator user has the root role. Okay, so I can actually su to root if I give the root password, and now I'm actually logged in as root. So now I can run as root. I can run privileged commands without pfexec. Okay. Over here, this user does not have the root role assigned to it. So this user cannot su to root. So even though I entered the password correctly, it says roles can only be assumed by authorized users. See, so what's going on is this is a security feature, obviously. So even if an attacker manages to break in to this account, this RBAC user account, the attacker is still, and even if the attacker knows the root password somehow, the attacker still cannot become root on the system, because you can only become root through a user who has been assigned the root role. Does that make sense? Sort of? Kind of? Yeah. How, from this account here? Yeah. So well, okay. So if a hacker came in, so that what the protection here is that there are fewer paths to getting to root. Okay, you can't log in directly as root, and you can only become root from certain accounts. So even if you get access to the system on Joe Blow regular user account, you still can't get root access from that account, even if you know the root password. Let's go back in the interest of time here. Let's talk about a little bit about sudo. So how many of you have used sudo? Right. Yeah, anyone with a Mac has, certainly. It's installed by default on OpenSolaris. So it's in user bin sudo, and then the configuration file is etc sudoers. It's not configured by default, but it's really quite easy to set up. So let me show you how this would work here. All right, so I'm logged in as root here, so I can just run the vi sudo command to edit the sudo configuration file. So what I'll do here is I'll set this up to essentially replace the primary administrator on OpenSolaris. So I'll just create an admin group here. Okay, so that gives all. It allows people in the admin group to run all the commands. Okay, so now all we have to do is we have to create the admin group. Okay, and then we assign the admin group. We'll use RBAC demo user, so we'll make our RBAC demo the admin. So we assign the admin group to RBAC demo. We will then pip exec. We'll take away because remember we assigned primary administrator to RBAC demo, so we'll take away the primary administrator role. That's what that command does. Okay, so now the RBAC user over here is set up with sudo. So you can see that the RBAC user now has the admin group. The RBAC user no longer has the primary administrator profile and does not have the root role. So yet I can still, I still get permission denied if I try and create a file in etc. But if I run it through sudo, right, it gives me the sudo thing. I enter my password, which is the password of this user. Oops. Right. Okay. So I entered the password of this user, not the root password, and then I'm able to execute the privileged commands. Okay. So that's the quick 10-minute overview of how least privilege works in OpenSolaris. So the summary is that out of the box, OpenSolaris is configured with RBAC, but you can, in a couple minutes, with the steps that I just did, you can convert to sudo if you prefer that. Okay? So any questions on that stuff before we move on? Yeah?
Does it also allow you to do things like file pushing
yeah, you mean like access control lists on files? Yeah. So OpenSolaris supports that with So we haven't talked about the file systems yet, and Dave's going to talk about ZFS, which is the default root file system. And so ZFS uses actually the NFS v4 ACLs, which are slightly different from the UFS ACLs. But we're not going to get into that in any detail today, but it is covered in the book. So, oh, by the way, I think we forgot to mention, we actually have 5 copies of this book to give away today. So stick around to the end, very end. 5 o'clock, we'll do a raffle for whoever's still here. Well, I'm hoping you're all still going to be here, but maybe this gives you a slight extra incentive to stick around. We'll do a raffle for the give away those 5 copies. We have T-shirts. We have T-shirts for everyone, so come get these at the break or afterwards. We have CDs, OpenSolaris CDs if you didn't get one in your bag, and one other book, I think, right? A little introductory book for OpenSolaris that for all of you as well. So come get those at the break or afterwards. All right, let's okay, so now that sort of covers the what we're going to talk about in OpenSolaris from the user perspective, and the rest of the talk is going to focus more on administration. So the first point that we're going to cover is OpenSolaris service management, and this is something that the OpenSolaris approach to service management was actually first introduced in Solaris 10, and it's quite different from the traditional Unix and Linux service management. So the traditional approach to service management, the System 5 approach or a Linux or whatever, is that processes are started by init scripts, and there's no concept of an overarching service, which might be a collection of more than one process, for example. There's no unified way to monitor or restart services. There's no unified way to administer services. There's no grouping of related processes, no explicit dependencies between services. So the service management facility, which was, as I said, first introduced in Solaris 10 and is, of course, an integral part of OpenSolaris, it adds the concept of a service, which groups related processes, and provides a unified mechanism to administer these services, to start them and stop them, and to specify dependencies, and to specify configuration properties. And thirdly, it provides an orderly startup and shutdown of the system, both startup and shutdown, following the dependencies that are explicitly specified by those services. So what is a service? There are 3 or 4 components to a service. There's a manifest, which is, all it is it's an XML file that describes the service. So it defines the dependencies that service has. It specifies the method scripts, which are how you start and stop the service, and it defines the properties of that service. So there's three more or less, 3 components to a service. Then separately, you have to write a start method script and a stop method script. And those are basically the same as your old, whatever you put in your RC directories to start stuff before that. It's just that they're called differently. And then also you can have a refresh script. So if a property is changed, then you can have a refresh script which will send SIGHUP to the application to get it to read the new property or something like that. So there's 3 new commands for administering services. The first is SVCS, which just shows you the state of the services. Second, SVC ADM allows you to enable and disable services. And then SVC CFG and SVC prop allow you to configure and retrieve service properties. So let me show you what this looks like. So, okay, so you run SVCS, you get a long list of all the services on the system. So you can see we've got, for example, the SSH is a service that is online. Okay, you've got, so SVCS-A will give you all the services, even those that are offline or disabled. So for example, I mentioned that the network services are all off by default. So for example, okay, so I turned that on myself. Bad example. I enabled that the other day. So Telnet, for example, is disabled by default. Okay. So let me... All right, so let's quickly take a look at what a service actually... Well, you know, I'm going to skip that just in the interest of time here. So let's take a look at how you actually start and stop services. So one nice thing about the service model is that it's not just the services that are traditionally part of the core operating system like SSH and Telnet. So for example, Apache Web Server is administered as a service on OpenSolaris. The MySQL database is administered as a service on OpenSolaris. So if I, for example, look at HTTP, we've got 3 services here. We've got Tomcat, Squid, and Apache 2.2, which are all disabled, right? So Apache is disabled, right? So if I go to localhost, I'm not gonna get anything. So what I can do then is go ahead and just enable Apache. That's not right. Okay. SVC ADM enable Apache 2.2. Okay, that's it. One command, and now Apache's online. Okay, I can connect to it from my web browser. So let me disable Apache. And then one nice thing about SMF is that it gives you really good error messages. So I'm going to edit the httpd.conf file. And I'm going to put a typo here. So, okay, so I put a typo in the file. So now, when I try and enable Apache, okay, I tried to enable it, but it's offline. So what's going on? So now, Apache is in maintenance mode. You see a maintenance there? Because of that typo. We know it's because of the typo, right? But if we didn't know that, we could run svcs-x, and it'll tell us, okay, Apache's offline, it's been in maintenance mode, it's not running, okay? So, and it gives us a log file to look at, right? So, we can, yeah, well, I don't have my mouse. All right, so if we look at that, if we look at that file, it tells us, okay, we've got an invalid command add on line 36 of http.conf, right, is in the log file for this Apache SMF service. So then we can go back and fix that. So that's, let's see. I think in the interest of time, I'm going to skip showing you how to change properties on SMF services, but that's actually covered in the book, and it's in the man pages as well, so you can look at that. So I'm going to now turn it back to Dave.
Okay, so I can elaborate a little bit on the question about porting of SMF. The userland stuff would actually be fairly straightforward to port to Linux. One of the issues that you'd find, though, is that SMF actually depends on some kernel functionality that was added to Solaris, a thing called contracts. And it's actually I actually covered it in the book a bit about how contracts work. But essentially, it's a mechanism for tracking process groups in a very much more fine-grained fashion than the traditional, kernel facilities for that. And I don't know enough about how that's done on Linux to say, how hard that would be or easy. But that would be probably the hardest problem that you'd have to solve in that. So, yeah.
It's like dying right away, so
yeah, so there are some things with SMF. SMF has, if it sees a service that's restarting too rapidly, that it'll end up throwing that into maintenance. The problem right now in the implementation is that that's actually got some hard-coded thresholds that are being, turned into dynamic stuff. But right now it's got some very simplistic rules about what it uses there. So. It's pretty much instantaneous. I mean, it's the thing with the contracts mechanism we put in the kernel. We get those notifications, immediately, and so that tends to happen pretty quickly. So we're going to talk about. We'll move on to ZFS and storage. So before we start talking about ZFS, which is the interesting part, we got to talk about a little bit of the basics of device naming in OpenSolaris. So when you're going to deal with storage in OpenSolaris, there's a nomenclature used for accessing your storage devices. And so it's what we call the CTDP nomenclature that's used on x86. And so it's controller, target, disk, and partition. So this is, it's somewhat of a logically topological view of your storage. So, which controller is this disk connected to, and which controllers may have multiple targets on them. If it's, say, an LVM controller, you might see something like that, and then devices beyond that. So there's. Yeah, some of this goes back. I mean, this goes back to the '80s. This nomenclature, so it's rather hoary in a lot of ways. The partitioning thing with x86 here is, the standard partitioning scheme that's used for dividing the disk. In OpenSolaris, partitions 1 through 4 refer to the primary partitions. Partition 0 refers to the entire disk. And with extended partitions, then there's partition 5 through 32, or whatever the limit is, that refers to the extended partitions, which I haven't covered here because that hadn't been done at the time I wrote the slides, but as I said a little while ago, that went in a little bit earlier. So the device nodes are actually located under dev disk. That's the actual devices that you'll find. So that's the basic disk naming on x86. If you're doing it on Spark, it's actually different. Which is always a source of interesting confusion for people. But very similar, though. We still have controller, target, and disk elements to the name. But then there's this thing called slice. And this is the what we call VTOC, or volume table of contents slicing scheme that's been used in SVR4 since the beginning. And actually, I think goes back to SVR3. That's used on Spark. On x86, we actually use it within the Solaris partition. So the model, and we'll go through a little bit of a diagram here in just a second. The model essentially is that we encapsulate a sliced disk within an x86 partition. And so we'll talk about it in just a second. So the file systems actually are on these devices. And the slices, there's 8 slices that are available. Although typically there was only 7 used because slice 2 is by convention the entire disk. And when we're laying out the ZFS at installation, we usually put the root pool on slice 0. So that's what you'll typically see. So here's just a quick diagram to try and pull those two things together that we covered in those last 2 slides. On the left, we have a disk, an x86. That's partitioned, and you've got partitions 1, 2, 3, and 4. Partition 4 in this case is a Solaris partition, and the others are whatever you make of them, any type that you want. And as you can see on the left, the partition 0 refers to the entire disk. So within partition 4, which is the Solaris partition, we then have the slices 0 through 7. And slice 2 is your reference to the entire disk. That's a convention. That's actually not enforced by the driver. That's a convention that we use within Solaris and OpenSolaris. So you can assign slice 2 to be a section of the disk instead if you prefer to, but you may find some old Solaris utilities that get confused by things like that. So that's the 2 minutes on device naming. It's a lot more to it than that, but that's enough for our purposes here. So then there's a bunch of tools for actually doing the partitioning. And on x86, there's a traditional fdisk command that does the very basic partitioning. We've recently added parted, the new parted library and command line utilities, and gparted is almost ready to integrate as well. So we'll have, the thing with fdisk is that it can repartition your disk, but it's destructive repartitioning. We're just moving boundaries and we're not respecting any of the contents within them. Parted allows you, and the libparted functionality gives you non-destructive repartitioning. So we can, for certain file systems, we can resize that partition and preserve the contents of that file system. Notably NTFS is the one that everybody really cares about because you get your laptops with Windows pre-installed taking the entire disk and you need to shrink them. So before Vista, there wasn't anything that Microsoft provided to do this, and Microsoft does now provide a utility in Vista. So parted that's been the common usage there. Some Solaris tools for slice management. Managing the slices, you've got format and a PRT, and that's how you actually edit the slices. And then the tool PRT VTOC, which allows you to just view them. For removable media, there's a whole bunch of additional tools, and this is one of the areas that I think we actually need to do a lot of work on in OpenSolaris. It's a confusing set of menagerie of tools from my point of view. But there's a thing called the Removable Media Volume Manager, which detects when I take my USB stick and insert it, it actually tries to automatically mount it. And we'll see if it'll actually do anything here. Well, sometimes it does, sometimes it doesn't. In some cases, you'll actually see some pop-ups of the disk being mounted up, and you'll see Nautilus launched. This one doesn't actually have anything on it yet, so there isn't anything for it to do. There's an eject command, which allows you to keyS the device before removing it. So, always nice to make sure you don't corrupt some of the older file systems that are not quite so hardened. ZFS, on the other hand, typically isn't so harmed by these things. And then there's a tool called RM Format, which allows you to view and format your removable media, and it's got some overlaps with the format tool. Again, one of those weird things that somebody did years ago that probably needs to be fixed. So that's kind of the basics on devices and disks. ZFS is the cool new file system that we've got beginning with Solaris 10, and we're especially making use of in OpenSolaris. So the thing we like to say about ZFS, it's really high-end storage for everyone. You don't have to go buy a big, massive storage array at some ludicrous price from some 3-letter storage provider to get you a lot of capabilities. So ZFS is really designed to run a pooled model of your disks and your storage. You plug your disks in, you configure them as pools. You've got essentially meta devices created by ZFS. It allows you that you can then slice and dice in pretty much any way you wish. And there's a lot of very interesting things that you can do as a result of this. You can have all sorts of virtualized storage on top of physical storage, and layers of virtualized storage. It gives you tremendous flexibility in how you manage your storage assets. High reliability, that was one of the key design principles. If you've ever dealt with having to FSCK some of the older file systems like UFS or EXTs or anything like that, what do you do when your system comes up and says, this is corrupt, I need to run FSCK? Okay, what's your answer? Of course, yes, please, I'd rather not access my data at all. ZFS, the idea is it's always stable. We don't need to go run fix tools to clean things up. Scalability, scaling up and scaling down. So, as I said, the high-end storage for everyone, being able to scale down the model so that anybody can try and use these things, even with very simple devices. And very simple, that's part of scaling down is ease of use, very, very tremendous ease of use. And the architecture is very flexible. The way ZFS is carved up, and we're not really going to go into the architecture here, but essentially it borrows a lot of ideas from memory management in the operating system, around and CPU scheduling, so that you essentially have we have a pipeline through the file system that manages moving the data in and out. And with that pipeline, we've got the ability to reconfigure how things happen, how the bits are moved. And so that allows us to do things like something that you may have heard of over the last few months, something called hybrid storage pools. And we've really exploited in a product called the Sun Storage 7000, which is a terrific storage appliance, where we can use solid state disks to provide a great deal of acceleration, both on read and write. And we're doing this, tremendously low cost and high performance. So ZFS, as I said, it's got a pooled model. zpool is your basic command for managing pools. And there's several different types of pools. There's simple single disk pools, which is when you install onto your laptop that's got a single disk, we create a simple storage pool with a single device. If you got multiple devices, then you can start doing a lot more interesting things. Concatenations, aggregating multiple devices into a single one, and just getting a sum of the parts in terms of storage. Or if you're more interested in reliability than in absolute capacity, you start looking at things like mirrors and RAID. And so we've got n-way mirrors, 2, 3, however many way mirrors you like. Or if you'd like something a little more sophisticated that gives you that same level of reliability without all without paying the ultimate cost in capacity, then you start looking at RAID capabilities. And RAID Z is a ZFS version of RAID 5 that we'll take a look at in just a couple minutes. So there's some really interesting performance and availability capabilities, and this is the pipeline that I was talking about a minute ago. Cache devices and log devices that allow us to cache data for reads, and log devices allow us to accelerate writes by offloading them from the main devices into lower cost, perhaps higher cost, but very high performance devices like SSDs. And of course, we've got spare devices for when you have failures and failover. The file system actually, the pools actually maintain an operational history, so you can go and actually look at what has happened to your pools. It's essentially a ring buffer, black box kind of history that's maintained of what's happened to your pools over time. There's dedicated performance monitoring with zpool IOStat, and we'll take a look at that in just a minute. So a couple tips around ZFS. You get the maximum benefit from pooling if you have fewer pools, because then you've aggregated your storage as best you can, and then you have the maximum flexibility to carve it up. So use as few pools as possible. Now there's reasons why you might want to use different pools, depending on whether you need certain, what kind of availability you wish to have for certain data, things like that will cause you to choose different configurations. And there's occasionally technical limitations that will drive you there too. The pools in ZFS are actually versioned. So there's actually a versioning scheme that allows us to evolve the file system and the pools as time goes on and recognize the format of the data there. You want to be very conservative about upgrading pool versions, which might seem a little odd. Generally we say, hey, use the latest things. The thing that you find, though, is and we see this a lot, is with the root pools that we install the operating system to, people will, I've just upgraded to a build 118 or whatever, and it's got some great new thing, and so I want to upgrade the ZFS pool to that new version. Problem with if you do that, and then you need to go back and boot an older version of the OS that doesn't have that capability, it suddenly can't read that upgraded pool. So you always want to make sure that, you know, your pool versions are no higher than the lowest version of the OS you want to run. So within the pools, so how do we carve up the data? So this is where we use ZFS data sets. So a data set's a term for really a file system, a volume, which in this case is a virtual block device, or for snapshots, which are point-in-time copies of either of the other two types. So these are the three kinds of data sets that ZFS has, and the ZFS command is how we manage them. We can delegate management of ZFS using a ZFS allow, so you can actually delegate the ability to users to create their own file systems within the file systems that they own. And so, you know, this is one of the other things to keep in mind with ZFS is, you know, when you're using a scheme for carving up storage like the partition and slicing devices that we talked about earlier in this section, you're very limited in the number of file systems that you can create, you know, because typically you map a file system to a slice or a file system to a partition, and that gives you, you know, and those typically are a limited resource of, you know, 8 or 10 or 30 or something that can actually occur on a disk. But with ZFS, you can have an arbitrary number of file systems. There's no limitation. And in fact, on, you know, this laptop, I don't know how many I've got. We'll take a look in a minute. But there's, they're your management boundary. This is where you can set properties on the file systems to have them behave differently. So as I said, there's properties. So there's a whole bunch of things. Properties are essentially how you configure a file system in ZFS. So you have sharing. You can share them over NFS, share them over the SMB CIFS protocol, share them over iSCSI. That's more for block devices, obviously, but you got multiple options here for sharing your storage resources across the network. Utilities for reliability and space. You can use, there's an ability to have ZFS automatically create multiple copies of your data beyond just what you might have with, say, a mirrored devices or things like that. This is actually something that ZFS does with its own metadata. That it will actually create multiple copies of the pointers between the various blocks. And this is how it, you know, one way in which it enhances its own reliability. And compression is something that's built into ZFS. So you can have it automatically compress your data, and you've got a choice of several different compression algorithms. Bunch of security properties, you know, ACLs, as we talked about a little bit earlier. There's a whole host of ACL things you can do. Control whether device nodes are available on the file system, whether you set UID executables are allowed, whether executables are allowed at all. And there's a lot more properties. And you can actually create user properties. And you'll see us actually use that in some cases with the operating system for extending the functionality. So question?
The question is that, is your right kind of like bottom of the compression experiment, or is it just something that this
So are your, yeah, what, you know, essentially what's the effect of compression on the performance? It certainly does have an effect. The way the writes are scheduled and such, that typically tends to, you'll see more, how's the best way to describe it? You'll see some latency effect. Typically, what you'll see with most systems these days is that especially with multi-core CPUs, is that we can actually do this without seeing too much performance penalty, you know, in terms of the observed application performance, although the utilization of the CPU will be much higher. So, you know, actually, you know, for example, if you got a multi-core laptop, it's actually really good to turn on compression because most of the disks that we use in laptops are really slow, but when you've got a 2, 3, or 4 core, 2.5 gigahertz processor in it, you've actually got a lot of extra resources to use to deal with that compression. So it's interesting. I don't have real good numbers to quote you on exactly the effects are, but yeah, that's what I've observed over the last couple of years. Yes. Yep. Yes, absolutely it is. The Z pool, there's one of the subcommands on zpool that allows you to attach additional devices to an existing pool. So we'll just do a quick demo on a RAID zpool. So I've got three. I hate it when this happens. So I've got three 1 gig USB sticks plugged into my system here, and so we're actually using the RM format utility that I talked about earlier to just see what those are. So as you can see, I've got three 1 gig Kingston Data Traveler USB disks, USB storage devices on here. So the thing we're going to do is we're actually going to create a RAID Z pool out of these three USB devices. So this is a great way to experiment around with ZFS for $5. Go buy some USB disks and play with them. So we'll create the Z pool. We did. We're done. There's your RAID. You can actually look at it here, and you can see that we've got those three disks. We've taken the whole disk in each case with partition 0, and you can see that it's online and ready to go. And you can look at it, there's a file system created automatically at the root of that pool that's the same name as the pool. So we created a pool named Z, and we've got a /Z file system that's already mounted there that we can start using. So I'm going to have OpenSolaris start writing data to it. We're going to take some data from dev_urandom, which is just random data that the kernel's generating for us, and we're going to write it onto that. So we started that. And with zpool IOstat, we can watch what happens as the data starts being written. And you can see we're writing along just fine. So you can look with IOstat, you can see the bandwidth that's being used for writes, and you can see the capacity that's going along here. And you can see we're really we're slowly filling it up here. We've got a long ways to go. This is 2.5 gigs that we ended up with out of this. But it's moves right along. So I've got this on a 5-second cycle for 10 iterations to show us what's happening with the operations. So you can see there's no read operations happening right now. So we're still online. So I'm actually going to pull one of these. Pulled one of the sticks, and you can see now we've got an unrecoverable error there. And as we can watch, it continues to write without any problems. And I'll plug that device back in. And you can see, so there's the removable media volume manager telling me that it can't do anything with that device. But you can see now, if you actually look at the data, look at what we're seeing in IOstat, we're actually starting to see some reads happening. And so what's happening is that while I had that disk unplugged, writes kept going on to the devices that were still there. Now we're in the process of resilvering that data onto this device that I just added back in. So you can see the read and write operations going on. So I'm going to kill the DD that was running. And then we can see now that it's, we've still had errors there, and it's in the process of working through the pool and resilvering it. And this one's interesting because we got something here that I've never seen before, where it actually said that there was a data error. That normally doesn't happen in this demo, so it surprises me all the time. But while we're at it, we'll just take a quick look at the pool history for that pool that we created, and we can see, that was created, and then there was actually some snapshotting that happened, and we'll come back and talk about that in a few minutes. So that's kind of a quick look at what a ZFS pool looks like. So ZFS is great in and of itself. It's a really cool file system. But one of the really neat things to figure out is, so what can you do with it? Once you got snapshots, the great thing about the snapshots of ZFS is they're fast. They're zero time, constant time essentially snapshots, because of the way that ZFS handles its data. So we've built this thing called Time Slider, which is essentially integrating ZFS with the GNOME desktop. And what we've done is we've added some services that automatically snapshot file systems using cron, build a tool for configuring that, and then integrate it into Nautilus, the GNOME file browser, the ability to browse the snapshot history and access the snapshot contents. So we'll go take a look at this real quickly. So we have Time Slider Manager is our tool for managing Time Slider. So as you can see, it's got an ability to, we can enable it or disable it. But what we have is a list of the file systems on my laptop here, and there's quite a few of them, as you can see. And so you can pick it to either have it snapshot all of them on a periodic basis, or you can select just specific ones. And in my case, I've only opted to snapshot a few of them, my home directory and a couple other things where I do a lot of my work. The snapshots are taken at several different frequencies. There's actually, if you look at the snapshot list for some of these file systems here, you'll see daily, hourly, monthly snapshots, and then there's really frequent snapshots. If we go down far enough, these frequent snapshots that happen roughly every 10-15 minutes, depending on what period you're using. So continuously, while I'm using this laptop, there's snapshots are being taken all the time of these file systems. And I can actually, with this screen, I can actually go and delete some of those snapshots, but we won't mess with that right now. So this is basically how you control Time Slider. Now, you actually want to use, if you actually want to use Time Slider in some way, we'll launch Nautilus on my home directory, and so you'll see there's this interesting new icon in the toolbar called Restore, which allows us to browse the snapshot history for this file system. And so I actually go, if I click that, you see now we have this little thing, this slider, which is hence the Time Slider name that we use for the feature, which tells us a little bit about the snapshots we've got available. So there's 46 snapshots taking up a fair amount of space of this particular file system. And I can slide along time and see the various snapshots that are happening and say, well, let me look at the state as of Sunday. And it shows me what was there at that point in time. You can see I got a lot of debris in this file system for some reason from VirtualBox. But if I can look back in time and say, hey, there's some, perhaps a file that I'd like to have back if I wanted to look around. So I'll actually go and look in one of my subdirectories here that's perhaps a little less littered with debris. So we'll go back and start looking at snapshots at this level. So this is just some development that I was doing, but I'm missing a file here, a 32-bit Lofi driver that I'm supposed to have. And I don't know what happened to it. If I keep going back in time, eventually find, there's Lofi 32. That's the one I was looking for. So I can do a quick copy with it, and then come back to now, paste it, and hey, whatever I did to fat finger and lose that, I'm saved from now. So this is, as a developer, source code management systems are great and all that. Once you check stuff in, and you can always get your revisions back. But while you're working as you go along, you've got this assistant working in the background, saving your data every few minutes. And so if you suddenly realize, oh, geez, that branch I was working with 15 minutes ago is actually the right one that I should have kept using, we can go back and you can go and get back to it. So this is, that's the quick thing in Time Slider. It's, really one of the cool things that we've done with ZFS, and something I really recommend people use. So I think we'll take our break now. We've got pieces of tree, I like to call the book. So let's talk about the software management in OpenSolaris. So this is, I mean, if you were to compare Solaris 10 to OpenSolaris, this is the area where things are most different. All the stuff that we've talked about up till now may not be exactly the same in Solaris 10, but at least for the most part, those features are there in Solaris 10. But software management is where we're doing some different things with OpenSolaris. The big thing is we're not doing SVR4 packaging anymore. We're really trying to modernize and build a much more capable software management system. So we're going to talk about a whole bunch of things in this section: the packaging system, boot environments, how to run IPS repositories, automated installation, and how to build your own distros. And that's a lot to cover in a very short period of time, so we'll dive right in. So IPS is the image packaging system is what IPS stands for. This new packaging system that we're building in the OpenSolaris project borrows some ideas from other packaging systems that you've seen in some other distributions and operating systems, but it's also got its own unique capabilities, and some of those have to do with exploiting things that are in OpenSolaris, like ZFS and SMF. So there's some different design concepts than in some of the other packaging systems because of that. So an IPS package, it's fundamentally it's modeled as a set of actions. So the fundamental unit in a package is an action. And there's a bunch of different kinds of actions. File actions, that's just a file in the file system. A directory in the file system. A link is a symbolic link. Then there's more complex actions, things like drivers, which is not just a file, but it's a registry adds some data to the registries in OpenSolaris that we use to associate drivers with pieces of hardware. User action creates a user account on the local system, group likewise. And then there's some special actions that allow us to express, depend action to allow us to express dependencies between packages. A set action, which allows us to put arbitrary metadata or attributes on a package. License action allows us to specify the license associated with the package. And then there's this thing called a legacy action, which we use to provide some level of compatibility between SVR4 packages that have been used in Solaris in the past and IPS. Basically, this allows an IPS package to emulate an SVR4 package from the point of view of the SVR4 packaging system, at least in a limited sense. And what we primarily do there is we're emulating the dependencies in SVR4. So to say you download a driver package from a third party like HP, which has, say, their storage drivers is a very common one. Typically that'll have some dependencies expressed on some core packages in Solaris. And if you tried to package add that driver, it would actually complain if those dependencies weren't present in the system. So with this legacy action, we can actually express that those packages, that functionality expressed by those packages is there, even though the package itself really isn't as far as SVR4 is concerned. So we've got actions, and then we've got a thing called a manifest, which collects up the actions to actually define the package. And then, so the I in IPS, image packaging system, so there's several types of images that we create. A full image is essentially an OpenSolaris instance. It's when we install the system, that's a full image. There's a couple other kinds of instances and images that are interesting, though. A partial image is what we use for OpenSolaris zones. And Nick's going to talk about zones in a little bit. But essentially, the way zones are constructed, they're dependent on the base system. So they can't really be their own full image. They have to have some dependencies with the base image. And so this is how we express it. And then there's a thing we've added called a user image, which allows users to install some packages on their own into their own areas of the file system. And this is essentially use the packaging system to distribute software rather than tarballs, of applications and things like that. That's really what we're trying to express there. So packages, we distribute them with IPS right now strictly over the network. There is, in fact, right now not a on-disk format of a package. That's something that we will be doing. But right now, you always install packages from a repository that's hosted on the network. We have the ability to move packages between repositories, but that is the path that's used right now. This question. Within a repository, they are a collection of files in various places. There's a repository directory structure. It's sort of like that, but not really. I mean, there's a whole lot of. It's essentially unintelligible what's going on in there because, in order to do some of the efficiency aspects of IPS, where we can, when we actually update, we only download the things that have changed. We actually store things, named off of hashes and things like that, so we can actually, we can compute very efficiently what's changed and what we actually need to pull over. So it's pretty opaque if you actually go look at it right now. So every package has a publisher, and if you actually look at some of the documentation, originally we called this an authority. So, publisher is something like OpenSolaris.org that distributes a set of packages. And we usually distribute those packages through repositories. Now, a publisher can have multiple repositories that provide different things. So, in the case of OpenSolaris, we actually have two main repositories that have essentially the same contents, the operating system that we're shipping, but they change at different rates. So the release repository is updated every 6 months or so when we do a full release, like OpenSolaris 2009.06. But then there's the development repository that's updated every couple weeks, as I talked about earlier, as we build each development build of the operating system. And each repository has a thing called a catalog that allows you to actually browse that. So this diagram just actually has the repositories that are available for OpenSolaris right now. So on the right, in the blue, are essentially a set of repositories that contain unencumbered content, is the term we use. This is all redistributable packages. They're licensed in such a way that we can make them available to all comers without a registration or anything like that. So there's the dev repository that has the development builds, the release repository that has the releases. There's this repository called Contrib, which we have a whole community in OpenSolaris that's porting thousands of open source packages onto OpenSolaris and making them available through this repository. So this is an area for the community to really make a major contribution to the success of OpenSolaris. And then there are project repositories. WebStack is one of them. We don't have very many of these yet, but we'll be having more of these as we go along, as individual projects start delivering IPS packages out of their own repositories while they're under development. So on the left, we have, in the yellow, a couple of repositories that have encumbrances on them. The extra repository, for example, is one that you've just got to register for so we know who's getting the software. It's for things that we can't redistribute freely, like Adobe's Flash Player is probably the most interesting thing there. Another thing that you'll find in that repository is the VirtualBox virtualization software. The support repository, so OpenSolaris, you can buy support for it. And by buying support, you get access to this repository where we make fixes available for the releases based on customer escalation, security, bugs that need to be fixed in between releases for those that want to use those releases in production. So IPS packages, they have names. They have this hierarchical scheme that's actually pretty complicated to look at, and I'm not going to spend a huge amount of time on here. Typically, you don't use the long names. Most of the time, if you're going to install the Flash player, you use package install Flash, and that just gives you the current version that matches what you have on the other portions of your system. If you want to install a specific version, you can use the second form that I've listed here, which gets you a specific version. And if you really want to go crazy, you can give out the full branch and everything name. Very rarely would you ever use this particular form of the thing. One of the things that we have done, and I'll come back to in a minute, is we've actually defined a way to integrate package installation with the browser using a MIME extension to the browser. So we'll take a quick look at how we can browse packages using the so let's resume this machine. So here I have the package manager GUI, which really should be your primary tool that you use for accessing the repositories. And so it comes by default populated to access the OpenSolaris.org repository. And so if you actually look at that, you know, the basic listing of all the packages in the repository is available. I'm having fun with my mouse. You've actually got the ability with this GUI to filter things based on packages that are installed, you know, packages that you don't have installed, if you're looking for stuff to install, and if you like to browse, packages that have updates available for them. And yeah, so there's all that basic browsing, but you can actually do searches as well. The search box we can look for. So I'm interested in adding GCC. I've got the runtime installed already in this virtual machine, but I don't have the compiler. So I could actually just select this development cluster, which has the compiler and some other things that go along with it. You can actually look down here at the bottom of the screen. You can actually look at the dependencies. So what are all the things that this is going to install? And it's actually going to install the compiler, the source code management, automake, things like that. So we could actually install here, but it'll take a while, so I'm going to skip that. But as you can see over on the left, we've got all sorts of different categories of software available. The main repository has around 1,800 packages per release available to it right now. The numbers are going up all the time. If we look at some of the other repositories, you've got ability to access quite a few more packages. So we can actually add more repositories. If we actually wanted to access that contrib repository, we can add the repository. And hopefully this will go quickly enough. Once we actually have that, this is going more slowly than I'd like, so we'll probably have to just skip this part of the demo. But honestly, it's very simple to add repositories, and we'll be providing more repositories all the time. Beyond using just the package manager, though, we can actually browse the repositories using Firefox, using your web browser. So if you were to look at package.opensolaris.org, it would look something like this. This is a repository I've got on my local system for performance and reliability purposes. But through the web user interface here, we can browse that same package set that we were looking at with the package manager. And we've got links here that we can actually go look at the details of each package, what size it is, take a look at the license. We've also got the ability to look at the details of the package, the manifest, so we can actually see the directory actions that create some directories, files that are part of the package, the license, dependencies. As I alluded to earlier, this driver action, this is a driver package. And then a bunch of metadata that describe the package, names and variants and things like that. So this is all very browsable. And again, we've got a search capability. Which this guy's really struggling with. But as you can see, this package doesn't actually, this repository doesn't have the GCC dev package that we were looking at in that other repository. But we have these, we do have the basic compiler package available. And if I wanted to install, I can actually initiate the install from right here, click on the install, and that would fire up the package manager to install that package. So we're not going to do that because that would be really time consuming considering the size of the package. But that's the basic idea. Beyond that, we've got command line, the command line that we can use. So we use package publisher to view the packages, the publishers that we're pulling packages from. And these are some internal repositories that I'm using on this system, internal to Sun. But we would actually use package list to list all the packages that are available that are installed on the system. Boy, really killing this poor laptop today. But essentially, we've got this. This is the list of the packages that are installed on the system. So that's a real quick introduction to IPS. So moving on from there in the software management, we have this thing called boot environments. So the idea here is we integrate ZFS with software management, and we make installing software safe. So if you've ever been in DLL hell in Windows or RPM hell in some of the Linux distros, where you've had, you install an RPM, you go to install an RPM, and it has dependencies that you need to add, and eventually you end up with perhaps conflicting dependencies versus other software that you're trying to use. A lot of times people have ended up in situations where their system basically becomes unusable due to the conflicts inherent in the packages there. So with boot environments in OpenSolaris, we use ZFS to install. First, when we're upgrading system, we always install into a copy of the system. So we're using ZFS snapshots and clones to actually install to a copy, so that if something goes wrong with that upgrade, you can get back to where you were before that, very simply. And in Solaris 10, we had something like this called Live Upgrade that was designed around UFS, but it was fairly crude in comparison because with UFS we didn't have snapshots and clones. We actually had to, we had to brute force things with CPIOs and things like that. So it could do some of the same things, but it was slow in comparison. So the boot environments have several different states. They're active or active on reboot or just mounted up. We have a little interface called BEADM that's used for managing them. So rather than spending a lot of time on this, I'm actually just going to do a quick demo of the boot environments. So we'll start by looking at the boot environments that I've got on my laptop, and I've got 3. These are named for the builds, the OpenSolaris builds that they contain. But the first one is B111B. That's actually the 2009.06 release that's on the CDs we're handing out. And builds 117 and 118 are the recent development builds that we've been using. So I can actually go and create an additional boot environment called the demo BE, which is going to be a copy of my currently active boot environment, B118. So I created that. And so now I'm actually looking and doing a detailed listing here of all the snapshots that go along with these boot environments. And so we've got, you can see here a snapshot was created of the built 118 boot environment that was then used to create a clone, which is the demo boot environment. And so I can actually look with the ZFS properties that's where that boot environment came from. And I can mount it up on /A here and actually look at it, and gee, that's just the top level of a full OpenSolaris installation. And now you can see when the BE Atom list output that we have that boot environment mounted. And then I can actually unmount it, and I can destroy it. So we didn't do anything with it interesting here. Yeah, and finished up by, we're back to where we were. We created a copy of the file system, the OS that we could have actually booted from at that point in time if we'd wanted to, and then we come back. So that's a real quick idea of what boot environments are like. Yes?
Pretty well ways in live upgrade right now. Solaris 10, and a lot of these, a couple of issues. One is on my laptop, I'm having a lot on my laptop.
Yep.
Unfortunately, to manage, which I'm very good, would be a way to do that without doing everything on my laptop.
Yeah, we haven't decided what we're going to do about that problem yet. We haven't. There's some complications around doing that. Our intention is that we'll at least be able to have OpenSolaris boot environments coexist with live upgrade boot environments side by side. Right now, you can't. But in the near future, that's what we expect to do.
And my other big concern is actually a Solaris 10 problem. One of the live upgrade policies activity zones, which is boot environments handle the zone that I
Yes, so the zones isn't totally integrated with the new boot environments yet. That's something we're still working on. Right now, right now what we have is pretty much equivalent to what's in Solaris 10 in terms of we can duplicate the zones. Right now, you don't get, when you live upgrade with zones, those zones actually get upgraded as part of that right now. That part is not integrated with the packaging updates that we're doing yet, but it will be. We're going to go beyond that, though, and you're actually going to be able to manage boot environments within zones yourself, which is not something that you can do with live upgrade right now. So when you actually go to upgrade the operating system, the command that you'd use is package image update. And you can do a dry run with -n to check it out beforehand, see what's going to happen. And you can also specify the boot environment name to be used when you actually create it. So we actually just did the demo here already. You can run your own IPS repositories. The code's obviously included as part of OpenSolaris. I'm not going to go into any great detail about this, but if you actually want to run a mirror of OpenSolaris.org, we've got instructions out there. It's very simple to run your own local repository. Populating it's a little bit interesting yet. The tools are a little crude yet for importing packages into it, but yeah, that's something that'd be really interesting. So a couple other things that we need that we want to use with that are part of the software management is the new automated installer. The idea here is to provide simpler automation than we had with Jumpstart and Solaris, but to also scale better out to WANs and things. We've had technology in Solaris around doing WAN installation for Spark that we never made available on x86, and we're going to be making that available on both platforms going forward. I'm not going to, since we're a little short on time today, I'm not going to go into a lot of detail about the automated installer. There's a lot of information available on the websites. But the thing I want to emphasize, it's going to be really easy. If you've ever tried to set up Jumpstart, it's an intricate, take a whole day kind of process to get it running. And with the automated installer on OpenSolaris, it's 3 steps. Install the tools. They are not part of the live CD due to space limitations. Download. There's a quick download with wget to actually, that actually allows you to download the boot image that's used for the automated installation. And then there's just a simple install ADM command that actually sets up the whole infrastructure on your server. And once you've done that, it's really simple. You just fire up and boot, and you've got it, and you can start doing automated installations. There's a lot of customization that you can then do from that point on, but getting you started is intended to be really easy. We're going to skip the demo here, so I'm running way behind. Another tool that comes along with OpenSolaris is the tool that we use to build the distribution, a thing called Distribution Constructor. Just one package you have to install. It's got a couple dependencies that it'll pull in. What it is, it's a very simple manifest that's used to define the build process.